first step is to specify the null hypothesis. For a two-tailed test, the null hypothesis is typically that a parameter equals 0, although there are exceptions. Typical null hypotheses are mu equals 0 and mu1 minus mu2 equals 0. The latter is equivalent to mu1 equals mu2. For a one-tailed test, the null hypothesis is either that a parameter is greater than or equal to 0, or that a parameter is less than or equal to 0. If the prediction is that mu1 is larger than mu2, then the null hypothesis, the reverse of the prediction, is mu2 minus mu1 is greater than or equal to 0. This is equivalent to mu1 is less than or equal to mu2. The second step is to specify the alpha level, which is also known as the significance level. Typical values are 0.05 and 0.01. The third step is to compute the probability value, also known as the p-value. This is the probability of obtaining a sample statistic as different or more different from the parameter specified in the null hypothesis, given that the null hypothesis is true. Finally, compare the probability value with the alpha level. If the probability value is lower, then you reject the null hypothesis. Keep in mind that rejecting the null hypothesis is not an all or none decision. The lower the probability value, the more confidence you can have that the null hypothesis is false. However, if your probability value is higher than the conventional alpha level of 0.05, most scientists will consider your findings inconclusive. Failure to reject the null hypothesis does not constitute support for the null hypothesis. It just means you do not have sufficiently strong data to reject it.